What's up, guys? It's me, Mr. C, and we're about to record a fun video here. I'm going to show you how to solve equations with common bases. So let's start with something real simple. If I had a base of x and I raised it to the power of a, I think that we could agree that it would be equal to a same base of x raised to the power of a. But, let me change the color here. If I say that the base is 3 and I raise it to the 2x power, and I have another base of 3 that's equal to the 18th power, what we could basically do is just ignore the base 3 and just set a new equation with just using the exponents. 2x equals 18. Solving for x, dividing by 2 gives us a value of x equals 9. However, sometimes they're not so simple. Like, take this one for example. We have a base of 6 that's raised to the 2 minus p power, and that's equal to 216. What we're going to need to do here, and some of you may know this already. Oh, hold on. I need to change my color here. It's not working. I'm still new to this, guys, but I'll eventually get it, hopefully. Oh, there we go. Now I got my color. So this 216 should have a base of 6. Otherwise, this problem wouldn't work out that well. So we are going to assume that it does. 6 to the 2 minus p power. But now we have to change this 216 and use a base 6. And that would be 6 to the 3rd power. So if I just used 6 and raised it to the 3rd power, that would make it so that my base would be the same. I would still have a base 6 here and a base 6 here. That didn't come out that nice. Let's try that one more time. And the base 6 there. So that means I can eliminate or just ignore the two bases and set the exponents equal to each other. 2 minus p, it's a p, and that's equal to 3. Solving for p, first thing I would do is I would subtract 2 from both sides, leaving me with negative p equals 1, and then dividing both sides by negative 1 gives me p equals negative 1. So to check this out, I plug the negative 1 back into the place of p. So this would be 6 raised to the 2 minus negative 1, or 3rd power. That should be 16. I found that before using my calculator. So 216 does in fact equal 216. Done. Now let's increase the difficulty just a little bit. We have now 64. Hold on, let me choose my color. We have a 64, which has a base 2. 64 would have a base 2, and 16 also has a base 2. So let's change these two values to have a base 2. 1 over, well, 2 raised to the 6th power gives me 64, so this would be 2 to the 6th. And 2 raised to the 4th power would give me 16, so that's 2 to the 4th, keeping in mind that I'm still raising this whole thing to the x power. If you have a power in the denominator that's positive, you can move it to the numerator as a negative. So that's 2 to the negative 6th power raised to the x equals 2 to the 4th. That negative 6 with the x there, because they're both powers, they can multiply. So then we would have 2 to the negative 6x equals 2 to the 4th. And now we're where we want to be. We can now set the two exponents equal to each other. So negative 6x equals 4, ignoring the denominators. And then we would divide by negative 6, divide by negative 6, and we would have x is equal to a negative, I'm going to reduce this to 2/3. I just substituted back my negative 2/3 in place of x. Our graphing calculators can do that in one step using the alpha f1 function, which gives you that n over d, the thing that looks like this. That allows you to put a numerator and denominator. So use that, check it out, and prove that 16 does in fact equal 16. Okay, last one, and this one is a bit tricky, not too bad though. Let's first choose a good color here. Alright, so now 27, 81, and 9. They all have a base 3. So let's change all these bases. Let's say 27 is 3 to the 3rd power, which then can be raised to the 2k as it was before. 81 is 3 to the 4th power, and that's raised to the 3k power. Oh, let me fix that. One more time, let's get that k. There we go. And then we have 1 over 9, which is 3 to the 2nd power. Let's simplify now. Let's go in there. If I do 3 times 2k, that means I have 3 to the 6k power times 4 times 3k would be 3 to the 12k power. Okay, messing that. Okay, and then 3 to the 2nd power in the denominator can move to the numerator as 3 to the negative 2nd power. Now, next thing I would do here, since the bases are the same and I'm multiplying, I could just add the exponents together. So that means I have 3 to the 6, I'm just going to write it out, 6k plus 12k, that's equal to 3 to the negative 2nd power. I could simplify that a little more, 3 to the 18k equals 3 to the negative 2nd power. And now let's eliminate our denominators, and let's do the solve the numerators. I'm sorry, the exponents is 18k equals negative 2. Divide everything by 18, and your value of k will be a negative 1/9. Alright, this video is already 6 minutes and 30 seconds long. I'm not going to check this one. You could just substitute that negative 1/9 into here and there, see if it works out. But as you can see, we did 3 good examples, starting with the basic of just the fact that x to the a is equal to x to the a.